propagation of errors or combination of errors. Mostly errors due to instrumental error, then personal error. Now, if I want to measure the length of this pen, the actual value, that is true value, of this pen is 5.5 centimeter. Now, I am going to measure this value first time. It shows 5.7 centimeter. Second time I am measuring and it shows 5.3 centimeter. Third time I am measuring, it is 5.4 centimeter and so on. These, when I am comparing these values with the true value, whether they are equal, no. So there are some errors while I am taking the reading. So if I substitute these values in the formula, the result will have some error. Error in the result is due to individual measurement. Second one is nature of mathematical operations. It includes addition, subtraction, multiplication, division, and the last one is power. Now, you will see error in the sum of two quantities. Let us consider two buildings. We will be, height of this building is A and the height of this building is B. If I add this thing, I will write Z is equal to A plus B. In physics, if I measure the height of this building, there will be some error. So that error, it will be represented in the form of delta. So actual height is A plus there will be some error. This delta A is called as absolute error. And this A is called as true value. If I add or subtract, then I will be getting it a measured value of A. I will be getting it as measured value of A. Here I will be using plus of minus. Why I am using here plus of minus? Now I will take this 5.7. I can write it as what? 5.5 plus 0.2. If I take 5.3, I can write it as 5.5 minus 0.2. So this 5.5 is nothing but what? True value. And this is absolute error. So I am writing plus of minus 0.2. So I am writing A plus of minus delta B. Like that for B, B is equal to B plus of minus delta B. Delta B is absolute error, B is true value, and this B gives actual value of B. Now we know that Z is equal to what? A plus B. Z is equal to A plus B. Now you substitute the value of A plus of minus delta A plus b. b plus or minus delta b. When I am adding these two values, the result will have some error. Let it be delta z. The result will also have some error. Let it be delta z, because there are some errors in these two quantities. Now we will add all the two values one together, plus of minus, add all the absolute error, delta a plus delta b. This is equal to z plus delta z. So z plus delta z is equal to a plus b is nothing but what? Z plus of minus delta a plus delta b. Z cancel here also, plus of minus we should add it. This plus of minus will be cancelled. So delta z is equal to delta a plus delta b. Delta z is equal to delta a plus delta b. The maximum possible error. Sum of two quantities. Maximum possible error in sum of these two quantities is equal to sum of two absolute error of individual quantities. This is called error in the sum of two quantities. It is clear. Now we will go one problem. It is example 1.5. It is given in page number 224. Two resistances R1 is equal to 100 plus or minus 3 ohms. R2 is equal to 150 plus or minus 2 ohms are connected in series. What is their equivalent resistance? What is given? R1 is equal to 100 plus or minus 3 ohms. R2 is equal to 150 plus or minus 2 ohms. What they are asked to find? Equivalent resistance, that is R. The solution. In 10th standard, you learn resistance in series. In resistance in series, so the effective resistance will be equal to sum of the two resistances. So therefore, R is equal to R1 plus R2. What is R1? 100 plus or minus 3 ohms plus R2 is 150 plus or minus 2 ohms. Now you add all the two values separately, then you add all the absolute error separately. So 100 plus 150 plus or minus 3 plus 2. So we will get what? 250 plus or minus 5 ohms. This is called equivalent resistance. Next, we will see error in the difference of two quantities. Next, we will see error in the difference of two quantities. Now, the same example. Let us consider two buildings. This one is A, this one is B. This height of A, that is this building height is A, this building height is B. Now, I want to find out the difference of these two buildings. How I can write? Z is equal to A minus B. In physics, if I measure the height of this building, there will be some error. So how I can write it? A plus of minus delta A. The delta A is nothing but absolute error. This A is nothing but true value. Plus of minus, if I add this one, we will get measured value of A. Similarly, we will get B is equal to B plus of minus delta B. Already it is known that Z is equal to what? A minus B. If I subtract these two values, surely the result will have some error, because when I am measuring A there is some error, here also when I am measuring B there is some error. So if I subtract these things, there will be some error in the result also. So I can write this result is equal to the result plus or minus delta z, plus or minus delta z. Why am I having this one? Because when I am subtracting this, there will be some error in the result. That is equal to what the value of A plus or minus delta A minus B. What is B? B plus or minus delta B. That is subtract these two true values. A minus B plus or minus. Always the absolute error should be added. We must only add the error. So I will be writing the delta A instead of minus. I will be using plus, because always the absolute errors should be added. You know that the value of A minus B is Z plus or minus delta A plus delta B. Z and Z cancel, plus or minus cancel. Therefore, delta Z is equal to delta A plus delta B. Delta Z is equal to delta A plus delta B. The maximum error in difference, maximum error in difference of two quantities. The maximum error in difference of these two quantities is equal to sum. Is equal to sum of absolute errors of in individual quantities. This will give error in the difference of two quantities. Understood? Here you will get difference. Here we will be using sum. Next we will go on problem. Example 1.6, page number 24. The temperature of two bodies measured by a thermometer are T1 is equal to 20 plus or minus 0.5 degrees Celsius, T2 is equal to 50 plus or minus 0.5 degrees Celsius. Calculate the temperature difference. Calculate the temperature difference and their error therein. What is given? T1 20 plus or minus 0.5 degree Celsius. T2 50 plus or minus 0.5 degree Celsius. What they asked to find? The temperature difference. The temperature difference. It will be T. It will be T. So solution T is equal to T2 minus T1 because we get value. So T is what? 50 plus or minus 0.5 minus what is T1 value? 20 plus or minus 0.5. So T2 value is 50 plus or minus 0.5 and T1 is 20 plus or minus 0.5. Now we subtract the true values plus or minus and add the absolute error 0.5 plus 0.5. So we get 30 plus or minus 1 degree Celsius. Is clear? Now we will see error in the product of two quantities. let measured value of A is equal to A plus or minus delta A. Now A is called true value, delta A is absolute error. Similarly, measured value of B is equal to B plus or minus delta B. Our question is to find out the product. So, if I multiply these two values, the result will be Z. Now, if I multiply these two values, since these values are having some error, the result also will have some error, and that error will be delta Z. So, therefore, Z plus or minus delta Z is equal to substitute the value of A plus or minus delta A into B plus or minus delta B. Now we extend this one. A into B in plus or minus A into delta B then plus or minus delta A into B then plus or minus delta A into delta B. Now you divide this equation. By Z. So Z by Z plus or minus delta Z by Z is equal to AB by Z plus or minus A delta B by Z plus or minus delta AB by Z plus or minus delta A into delta B by Z. This Z and Z cancel. So 1 plus or minus delta Z by Z is equal to AB by B more than Z is equal to what? A into B. So you substitute in the value of Z. So I will write AB plus or minus A delta B by AB plus or minus delta A into B by AB plus or minus delta A into delta B by A into B. Now see this A and A cancel. A and A cancel. A and A cancel. Then B and B cancel. So now we can rewrite 1 plus 1 plus or minus delta Z by Z is equal to 1 plus 1 plus or minus delta B by B plus or minus delta J by J plus or minus delta J into delta B divided by AB. Here. Now this 1 and 1 will be cancelled. Now I will write plus or minus delta Z by Z is equal to plus or minus delta B by B plus or minus delta A by A plus or minus delta A into delta B by AB. Now let us consider this value is 0.1 and this value is 0.2. Now you substitute here, multiply these two values, I will get what? 0.02. I will be getting that 0.02. If I multiply these two values, I will be getting 0.02. That is very small. So that I can neglect. So this value I can neglect it. So now we can write plus or minus delta Z by Z is equal to plus or minus delta B by B plus or minus delta A by A. So plus or minus delta Z by Z is equal to plus or minus, you take it common, So delta A by A, delta B by B. Already I already told that the absolute error always we should add. So I will put plus symbol. Now plus or minus we cancel. So therefore delta Z by Z is equal to delta A by A plus delta B by B. So now I can define error in the product of two quantities. The maximum fractional error in product of two quantities is equal to sum of fractional error in individual quantities. Clear? So example 1.7, it is in page number 25. The length and breadth of a rectangle are 5.7 plus or minus 0.1 centimeter and 3.4 plus or minus 0.2 centimeter respectively. Calculate the area of the rectangle with error limit. What is given? Length. Length is equal to 5.7 plus or minus 0.1 centimeter. That is given. That is equal to 3.4 plus or minus 0.2 centimeter. Okay. Now you see this one. It is in the form of A plus or minus delta A. This one it is in the form of B plus or minus delta B. Now how I can write this one? L plus or minus delta L. Here B plus or minus delta B. Here. Now what is the value of L? 5.7. What is delta L now? 0.1. Here B 3.4. What is delta B? 0.2. I think it is clear for you now. Now what we have to find? The area of the rectangle with error limit. We have to find area with error limit. We have to find out the area with the error limit. Now we will go for solution. First we will calculate area. So area is equal to what? Length into breadth. What is length here? 5.7. What is breadth? 3.4. If I multiply this, I will be getting 19.38 centimeter square. 19.38 centimeter square. Next, we will go for error limit. So, we are calculating area for this area, that is error is delta A. So delta A by A is equal to delta L by L plus delta B by B. Understood? Now I want to calculate delta A. So delta A is equal to delta L by L plus delta B by B into that A. Clear? Now what is delta L? 0.1. What is L? 5.7. Plus delta B 0.2 and B value is 3.4. And what is A? 0.1 divided by 5.7, I will be getting 0.0175 plus 0.2 divided by 3.4, I will be getting 0.0588 into 90.38. If I add these two things, I will be getting 0.0763 into 90.38. If I multiply these two values, I will be getting that 1.48. If I round off this one, I will be getting that 1.5 centimeter. Now what the question? Area with the scalar limit. So therefore, area with scalar limit is equal to what value we got for area? 19.38. And this is scalar limit. Plus of minus 1.5 centimeter square. Clear?